we'll get to that in a minute. And again, I calculated that same thing, the percent of cases that were sold on promotion. And again, notice that before they hired the social media manager, that the percent was pretty constant at around 0.5, right? About 0.5%. No, I'm sorry, about 50%. That would be 50%. Then what happens afterwards? Again, it rises, but you see these huge spikes, so it goes from 50% to 250% at some point. And again, a huge variance in the use of promotion.
How is promotion measured?
That's a good question, because you're going to have to use this in the data. So promotion is defined in the Nielsen data as, there's 3 types of promotion. There's feature, display. So feature is any kind of mailer or newspaper coupon, newspaper ad, an insert in the newspaper, or perhaps a mailer that they send out to you. So feature is, that's feature. A display is any kind of in-store display. So the shelf talkers, the little flappy things that they have at the shelf. End caps, the cases of wine at the end of the aisle. Even moving those by, moving them by the register, the cash register, that's a promotion, that's an in-store display. When I buy meat at the grocery store by the meat counter, they'll have meat there. I'm sorry, they'll have wine. They'll have meat at the meat counter, but they'll have wines there, and they charge you to put your wine there. So that's an in-store display. So features are usually outside of the store in terms of mailers and stuff, and display is defined as anything inside the store. And then there's feature and display, because you can do both. So there's feature, display, feature and display, and then there's something called the temporary price reduction. And those are different than sales in that they're exactly what it is. So they're trying to move something, so they have it's a markdown. If you ever see that basket of goods kind of near the checkout stand where they just throw a bunch of stuff in there and it's like $1 or something, those could be examples of temporary price reductions. So it's usually with them trying to get rid of inventory, and they temporarily reduce the price, and it's different than a sale. But it's, I think that the definition is that it's 7 days, it's less than 7 days.
So is all of that measured by the store that's selling the wine?
Exactly, and it's measured in the scan. So when you scan it, they know how much you bought, the quantity, they know the price you paid, and they know whether or not it was on promotion. So it's all captured in the Nielsen data, which is pretty cool. Which is why Nielsen data is so cool. And you're going to have this data also. So we're going to calculate this stuff, these kind of these percent of cases promoted. All right, so, and we can see again that coincides with the uptick in sales. One of you guys mentioned, the other thing is distribution. Distribution is, right, not all wines are distributed at every grocery store. For example, Safeway might have a different set of wines. Safeway absolutely has a different set of wines than Raley's, which will have a different set of wines than Ralph's, which will have a different set of wines than Costco, which will have a different set of wines as the other grocery stores. So it could be that sales grew because those wines, St. Supri, pushed for more distribution. They started penetrating more markets. So we don't really have a measure of distribution, but something in the Nielsen data called ACV is in the data, in the data set. Anyone know what ACV stands for? It stands for all commodity volume. And basically it's basically a measure of distribution. It measures what percentage of stores that sell wines are your products carried in. So in essence, and it's not exactly a measure of distribution, but it's a measure of distribution. It's about as close of a measure of distribution as we can get, and it's readily available in the data set. So we're going to use ACV, all commodities volume, as a measure of distribution. And in this case, it looks like they were actually losing retail channels a bit. But that trend had started somewhat before, so that could have contributed to the declining sales to begin with. Finally, I looked at income. And basically, I needed to use some measure of income. So I used something called personal consumption expenditures. And this is data you can pull from the Federal Reserve database online. It's called FRED, Federal Reserve Economic Database. And essentially, what personal consumption, the reason I didn't use GDP, and they're really closely correlated, highly correlated, so there probably wouldn't have been much of a difference. But personal consumption expenditures measures what people spend for consumption. It's a little different than disposable income. It's literally what people spend on personal consumption. So to me, it sounds like a much better measure of what's available to spend on things like wine. So I extracted that from the Federal Reserve database. I imported it into my wine database. And this is one of the things I wanted to get you guys used to, is being able to merge different data sets. So go to the FRED database, pull that data out. It's already, bless you, it's already in Excel format. You can download it in Excel format. So it's ready to go back into Stata, and then we can merge the two Stata files. And again, that's a good exercise in and of itself. But there's the Great Recession, the worst recession since the Great Depression. And you can see that little notch there. Let's see, December 2008 was the crash in personal consumption expenditures. 2009 was the official end of the recession, but it wasn't until 2010 that personal consumption expenditures reached their pre-recession peak. And what I mean by that is that if you think of the pre-recession peak as this point here, if you were to go all the way across to when they reached their pre-recession peak, that occurred in April of 2010. So clearly there was a significant economic event going on. And if we superimpose our measure of case volume in there, then at least a chunk of that decrease. And you can kind of see, if you look close enough, you can kind of see they were declining a little bit here, but it looks like there's a bit of a significant decline right here at the depths of the recession. And sales were relatively stable, maybe a little bit of decline, but if we probably measured just that small time frame, it might be negative, but not much. But clearly they fell by far the most as a result of the Great Recession. And when the economy started to pick up, sales started to pick up. So we got lots of factors that contribute to the change in sales. So if we have all these factors, what would we want to do? That's the first thing we always do. Run a regression. We need to build a regression model and see if we can explain. Remember, what we don't have is we don't have social media buzz. I don't have any kind of measure of social media buzz. I tried to get it from a person I know that measures social media buzz. At least they used to. They're out of business also. Anyone ever heard of Vintank? Yeah. So they used to be a social media measure social media buzz for the wine industry. And what's his name? Paul his last name? Forgot. But I should know because I actually did some business with them. But I asked them for the data, and they said, yeah, sure, they'll give it to me, and they never did. They went out of business. So I don't have any measure of social media buzz. So what I want to do is use the factors that I do have and just answer a simple question. Does price, promotion, income, and distribution, do those four factors explain sales? Explain the change in sales? In other words, how well would our model fit the data? If this entire reversal, if this entire V shape is explained by those four factors, then that really doesn't leave a lot left for social media to explain, right? And that's really what we're saying. So we're taking sort of a residual effect, a residual approach. If I can explain this V pattern in sales by these four observable factors, then again, it doesn't leave much room for social media to have much of an effect. Does that make sense?
Yes.
So we're really approaching this in a pretty simple but methodical process. We're not, we're not taking a whole lot of leaps of faith. We're just saying, can I explain this change in sales caused by other things? So, building the model. We're going to use these factors, price, promotion, distribution, and economic growth, and see if we can't predict sales. And then, perhaps we might want to ask, if we can predict sales, do the predictions get any worse after the hiring of social media manager? So here's sales, and we're going to run a regression with those factors, and that's how well the model fits the data. What's that?
Doesn't look good for that.
It doesn't. That looks pretty good. It doesn't look good for the social media manager. That means we're able. I mean, look at it. It picks up the entire downward and upward trend explained by those four observable factors: price, promotion, distribution, and economic growth. Explains that entire change in sales. Not 100%. Remember, we never get 100% R squared. But that looks pretty good to me. That looks pretty.
Can you go back to the last slide? I just want to make sure I write something.
This one?
Okay.
Yeah, that looks pretty good to me. And again, it doesn't look good for the social media dude. The guy who quit because of his huge success to go start his own consulting company. Adjusted R squared is about 82%. So 82% of the variation in sales is explained by our observable factors, our model. That's pretty good. That's pretty good. And again, remember, we got some wackiness going on. We got the worst recession since the Great Depression. You had these changes in prices, promotion. Does the fit of the model change? Let's see. What I did was compare the pre-social media and the post-social media to see if the model gets any worse. And there is the prediction for the pre-period. So basically, I ran a regression just for this period. Then I ran a regression just for that period. And I wanted to see if the fits differ a whole bunch. And not really. I mean, it still looks like a pretty good fit. Is it perfect? No, but we never get a perfect fit. And we kind of ballooned up that post period.
Bless you.
And what I did was, bless you. What I did was I showed the prediction using the full data set, and then the prediction using just the post social media hiring data set. And so you can see the maroon and the orange are pretty close, Here's the actual data. So there's our 82 R squared. For the pre-period, the R squared actually goes up a bit to 83. And for the post-period, it does go down a bit to 0.57. And I was looking at that, I'm trying to figure, why is the R squared so low? But let's look at a couple of things. One is, look at the effective price in the post-social media period. The coefficient's negative, and these are log prices, by the way. Coefficient's negative, but look at the size of it. It's 0.07, and it jumps to 0.10. So price becomes more important after they hired a social media manager. Why? Because they lowered price. Because they used price a lot more aggressively after they hired a social media manager. Look at the effective income. Income doubles in size. That is, the economy became twice as important after they hired a social media manager as it was before. That coefficient literally doubles in size. Which makes sense because we're coming out of the worst recession since the Great Depression. Aggressive pricing, aggressive promotion. Oops, I didn't get the promotion. Aggressive or positive economic growth. Promotion becomes less important, strangely. But we do know that they promoted more aggressively, but they were, if you remember that graph of promotion, it was just all over the place. It looked like they were, I want to go back to it, but it looked like they were flailing. They were trying everything, right? Aggressive pricing, and they were really aggressive with the promotion, but that would jump up to 250% and then jump down from week to week. The variance in that was really all over the place. So I think that's the reason why that the coefficient on promotion is smaller. It's because the correlation between promotion and sales wasn't as closely related, even though, let's just go back a bit. It was literally, go back. It was hovering at some amount, and then it jumped up, but it was doing this, right? Remember that? So, and then sales started to rise, but the correlation between the two isn't as strong, even though they're promoting a lot more aggressively. Sometimes, or a lot of the times, they're also reducing promotion. So the variance in promotion was just all over the place. And I think that's why promotion is less significant of a fact, not less significant in terms of its significance, but the size of the effect, the magnitude of the effect is smaller because it just, like I said, it was like they were flailing with their promotion. But clearly we saw promotion was being used more aggressively in afterwards. One of the things, we're not going to do it, and I'm fine leaving it because I'm fine with the way things are working now. But one thing we might want to do is smooth this out a little bit, right? Just so there's not so much variance. And we can do that with the moving average. We did all that stuff, kind of moving average stuff. I don't like to play with the data. I don't like to manipulate the data too much. But in this particular case, I think if we smooth out those wild swings, and again, it's like I said, it's just flailing. If you ever see that, just throwing punches all over the place. They're just flailing with their promotion. I think if we smooth that out a lot, kind of like with price, that coefficient would be a lot larger. It would be bigger after than it was before. I just think there's too much wild swings in their aggressive use of promotion.
So how would you interpret that coefficient? Say like every $1 increase in promotion caused a 0.16%?
So remember, promotion is already a percentage, and notice I didn't take logs of it. So we can treat log price, because log cases, we have log cases, price elasticity and income elasticity. So promotion is already percentage, so you can say that's for every 1% increase in wine sold on promotion, since it's already a percentage. So for every 1 percentage point increase in wine sold on promotion, sales go up by 16%, something like that. So, yeah. Distribution was really not important. It's not significant across there, but we saw that. We saw distribution was actually declining over the entire data set. So, and distribution didn't change at all, so it wasn't much more significant. The R-squared does go down, so the fit does decrease, although visually you wouldn't think that. I mean, when we look at those regressions, it looks just as good before as it does after. And I think, again, this comes down to a couple of things. One, the effect of promotion again. I think promotion, the fit with promotion, even though it's statistically significant, the correlation just, like I said, it's hard to map out that correlation, and it's a weaker relationship. The other thing is that I used a linear time trend, and we've used that before. And a linear time trend is just that, it's linear. It goes in one direction. Straight lines don't change direction. So I don't, perhaps what I should use instead of a linear time trend is maybe a, let's go back. That's the post. Perhaps instead of a linear time trend, I use something that can account for this nonlinear shape, such as a, what'd you say?
A parabola.
A squared term, exactly. If I throw in time, instead of a linear time trend, I throw in a quadratic time trend, it's going to capture that U. So I think that's why it's, because the pre, it's capturing a time trend, and then that time trend changes. So according to time, that should still keep going down, and it doesn't. But I think if I put in a parabola, or a U, a squared term for that, then our fit would be better. Or I can construct an interaction, before and after interaction, so that I allow the time trend to change before, after relative to before, so that it will account for positive growth instead of negative growth. But if you look at the fit looks, they both look about equally well-fitting. Yeah, and this is the, this is just the post. So, and if you look at the two regressions, the full, which is an R squared of 82, versus the post, which was an R squared of, I forgot what it was. They don't look that much different. They really don't. I think it's those two things. I think it's promotion just going wild, and the time trend not going the wrong direction, in essence. Not the end. The New York presentation was pretty good, but the YVI in Paso Robles, I was chased all the way to my car with people telling me that why this is wrong. Before the iPhone, don't ask, I don't know. the iPhone is the game changer. When it came out, social media really took off. And I said, okay, that's fine. That even keeps it as a control. Actually, what they said was, how many of you have, when did the iPhone come out? 2007. Yeah, so they said that the iPhone coming out, really caused social media to explode. And I said, that's even better because that means social media should have an even bigger effect. But yet, I'm still able to explain sales with my 4 factors. So, but we've got to remember, this is a conference. These are big auditoriums. Just with a couple hundred people in a giant. It's held at the fairgrounds in Paso Robles, whatever county that is, whatever county fairground. So it's a big room, all of whom were social media managers. So every one of these people's job is, they make their living off social media, and they weren't too happy. One of them was, anyone know Ron Sharman? He teaches here. He has a social media company also. And he was there, and I saw him beforehand. I said, hey, make sure you don't miss my presentation. You're gonna like it. And he didn't like it. He didn't talk to me at all. He still hasn't talked to me. Which is too bad, but it's not like we were Facebook friends or anything. So, any questions? This is really one of the best ways you can do it, is try to see, okay, if you had an effect, then let's see if we can measure it using some regression-based technique. So let's look at the data. So I'm going to present this at this conference in the summer. If you were going to pay to see that conference, I just saved you a couple $100. Tasting room, cannibalization. Why do I have? I got 2 cannibalizations. That's a lot of cannibals. Social media. All right. So what do we got here? Describe. So this is a. Usually I exclude a lot of these variables from our data sets, but I kept this one a little bit more with a little bit more of the data. So. Period, again, we'll look at the period. This is a 4-week ending data. Market item, again, is the SKU. Varietal size. This is the only, let's see, the only item in here, tab. The only brand in here is St. Super. So what is all this other stuff? A lot of it we don't need. But a lot of this is really cool stuff. So when we're looking, so brand family is the overall owner of all the individual brands. The NP stands for non-promoted. The P stands for promoted. And then the individual F stands for feature. D stands for display. F and D stands for feature and display. And then TPR stands for temporary price reductions. So if you look at here, cases, normally I just give you cases. And this is cases of all these categories, promoted and non-promoted. But now we can identify which cases sold were on promotion and what kind of promotion they were on. Now we're not going to really care about what type of promotion. We'll deal with that stuff later when we deal with promotion. But really we just want to look at cases sold on promotion, which is cases P, and then cases sold off promotion, which is NP. And we're going to take the ratio of those two. And we just want to see, okay, what percentage of cases are sold on promotion versus off promotion. So pretty simple. And we also have those designations for all of our variables, price, revenue, which I don't normally give you, but revenue is just price times cases times 12. So this is a lot closer to the true raw data you would get from Nielsen. Nielsen charges you for everything, by the way. Okay. And the final variable we're going to look at is, that's in the data, is ACV, and again, that stands for all commodities volume. And it's, like I said, it's not exactly a measure of distribution, but it's pretty good. It's a pretty close proxy for distribution. No, nobody's heard of ACV? Nobody's used it before? Yeah, it is in the raw data, and you do have to ask for all these things. Like I said, Nielsen's going to charge you for pretty much everything. All right, the one thing that is not in here, did I not bring it? No, it is in here. And then PCE is personal consumption expenditures. All right. Let's see, candles. Social media. All right. So this is a new problem we haven't had to deal with. Notice the dates. And again, this isn't me. I didn't artificially do this. But notice the date has this contained in the data field, 4 weeks ending. And here's what we want. So sometimes you're going to come across data that's not, again, set up for us to analyze. We want those dates because we want to construct the monthly dummy so we can count for seasonality. We want to construct a time trend so we can count for time, for any trend in sales. So we want to do all that stuff. But normally we convert the date to a stated date, and we can't necessarily do that using the same commands. But Stata, being what it is, allows us to extract out just that portion of the data we want. So let's see. If this was in, you could actually do this in Excel if you wanted to, using, what is that?
Text to column.
Text to columns, exactly. And that kind of slices up data that's all in one cell. You just tell it where to slice it. In the same context here, we can do the same thing